Calorimetry is a great way to determine the enthalpy change for a particular reaction. And this way we can measure the heat released or taken up by a chemical reaction. So consider a simple calorimeter. You have a styrofoam cup, and you have a solution in it. You have a lid that fits loosely to keep it at constant pressure. And we have a thermometer in the bottom of a thermometer suspended in the solution so we can measure the temperature. And then we let a reaction occur in solution, and we can, I keep writing G's, Q's, we can measure the heat by the change in temperature of the water solution. So Q for the calorimeter is equal to negative Q for the reaction, or negative Q for the calorimeter is equal to Q for the reaction, depending on the direction of heat flow. If you get the sign wrong, as long as you have opposite sign, you'll get the same answer. Opposite sign for calorimeter and reaction. Okay, Q for the calorimeter is going to be the mass of the water, specific heat of the water, times the temperature change of the water, since we're running the reaction in water solution. And then we can determine from that, from the temperature change, the heat given off or taken up from the reaction. Okay, consider an example. We have, say, magnesium solid plus hydrochloric acid dissolved in water. And that will react to give magnesium chloride, which stays dissolved, plus hydrogen gas. The hydrogen gas can bubble out of solution, and since the top is loose fitting, it can escape from the cup, keeping it at constant pressure. So that way heat is equal to enthalpy change. And so we take 0.16 grams of magnesium reacted in the solution, and we find the temperature change goes from 25 degrees centigrade to a final temperature of 32.2 degrees centigrade. And we have 100 milliliters of solution, which we are approximating as pure water. If we have a dilute solution, we can just use the specific heat and density of water. So the density of water is equal to 1 gram per milliliter. So that means 100 milliliters equals 100 grams of water. So the heat for the calorimeter is equal to the mass of the water, specific heat of water, and the temperature change of water, which is 100 grams, 4.2 joules, gram degrees centigrade, and the temperature change looks like 7.2 degrees centigrade. So Q is equal to 3.0 kilojoules. This is the heat absorbed by the water. So the heat given off by the reaction is going to be negative. So that's heat for the calorimeter. So the heat of the reaction is going to be negative 3.0 kilojoules. So this is 3.0 kilojoules negative per 0.16 grams of magnesium. We can convert that to moles of magnesium by using its molecular weight. So this will give us negative 455 kilojoules per mole of magnesium. Should write of here. So I can say that delta H of the reaction is equal to minus 455 kilojoules as written, because since I have 1 mole of magnesium in the balanced equation.